Here we go. Some review, and these exercises are pretty much review things you should already know. How do you multiply x plus I times x minus I and write it in standard form? So that's going to be, just distributing. So x times x, x squared. And see other conjugates, so we're going to save time. We're going to save time by not worrying about the whole distributive, just doing the first times the first and the last times the last term. So I times negative I squared. X plus 5i, x minus 5i. So we have x squared. Again, they're conjugates. Minus 25i squared. Okay, so that's going to be x squared plus 25. Now, after doing those two, I'm going to hold off on this. I'm going to skip down to here. Because here they're asking us to factor each of the following polynomials. Now, let's think about it. Take a look at what they're asking us to factor. They're asking us to factor x squared plus 1. We have x squared plus 1 right here. What are the factors? The factors are what we multiply by to get x squared plus 1. Well, it's right here. It's right here. Those are the factors. X plus I, x minus I. See that? And then x squared plus 25. Here it is. There it is. Here are the factors. X plus 5i and x minus 5i. All right? So that's kind of making relationship between what you get when you multiply it out in standard form and the factors going backwards. So this is going forward, this is going backwards. Okay? Now, let's say I didn't have those answers sitting right there. How would I do it? Well, we're going to do x squared plus 9. I'm going to show you how you could do it. Don't worry, we're going to go back up and do the other one. X squared plus 9. Here's how you do it if the factors weren't sitting up in the exercise 1. What you could do is pretend it's an equation even though it's not. Set this equal to 0 for a second. And you'll get x squared equals negative 9. And then take the square root. And you get plus minus 3i. We've done this, right? We've done this. You get plus minus 3i. Okay, so now we got to think. If 3i and negative 3i are my solutions, like, let me back up a little bit. What if, blank page, what if x equals 3 and x equals 4? What if those were your solutions? Well, we would know that factors were x minus 3 and x minus 4. Okay, does that make sense? If you had solutions of 3 and 4, we know our factors are x minus 3, x minus 4. We've been doing that like forever, okay? So it applies to imaginary numbers as well. If I know that 3i and negative 3i are my solutions, I know that my factors must be x plus 3i and x minus 3i. Basically x and then change the sign. The plus 3i is going to have a minus 3i, x minus 3i, and the minus 3i solution is going to be x plus 3i as a factor. Okay, so you just change that sign and you get your factor. So this is x plus 3i, x minus 3i. And you'll kind of get the hang of it as we do that. So again, these cannot be factored over the real numbers. Those cannot be factored with real numbers. You need imaginary numbers to factor each of those. Now this one here is kind of... if 2 plus I, if I had x equals 2 plus I and x equals 2 minus I, if those came out to be my solutions, these would be my factors. X minus 2 plus I, x minus 2 minus I. Kind of looks weird, but that's what it is. X minus the number, x minus the solution, and x minus the solution. The solution is 2 plus I, and 2 minus I. Got it? So x minus 2 plus I and x minus 2 minus I. Now, how do I get this in standard form? Well, we're going to have to use our tabular method to do this because it's a 3 by 3. So this is x minus 2 minus I. You have to distribute that negative. And this is x minus 2 plus I. That negative has to get distributed through. See that? Now I need my tabular method. Oh, I need 3 by 3. Mr. Ventry. All right, so I have x minus 2 minus I. I know I didn't give you a lot of room. X minus 2 plus I. All right, so x times x squared. I want you to pay attention to what happens here when we do the tabular method with i's. This is minus xi. X times negative 2, negative 2x, plus 4. And this is plus 2i. And this is xi and minus 2i and minus I squared. Negative I times I minus I squared. Minus I squared, guys, is just 1. Minus I squared is 1. I want you to pay attention to what happens with our i's. Look at this. See this diagonal here? 2i minus 2i, that's 0. This diagonal is not all i's, but it doesn't quite work out that way when you have the tabular method with the 2 in the middle there. But xi minus xi minus xi, that is 0 as well. I still have that 4. What's left? X squared minus 4x, and then 4 and 1 is 5. So look what I get. I get just a regular quadratic, x squared minus 4x plus 5. Because if I solve that out, this quadratic, see, is going to have answers, solutions of 2 plus I, 2 minus I, 2 plus minus I. All right? That's where it comes from. So this is kind of the connections we're going to be making in this lesson. These are just exercises to get us ready. Question, can a polynomial equation have just one complex solution? Can it have just one complex solution? Well, so in other words, can I have an answer? Can I have x equals 3 plus I without having 3 minus I as a solution? Well, the answer is no. The answer is no. So can I have just that? No. If I have an answer of 3 plus I, I must also have an answer of 3 minus I. Complex solutions come in pairs. So if you know that 2i is a solution to a polynomial equation, can you find the other solution? Yes. If 2i is one solution, then negative 2i must be the other solution. Okay, it's conjugate. It's the conjugate. So a complex number and its conjugate will always be solutions. When you have one, you must have the other one. And we're going to need that later on in the lesson. Okay, so here's exercise 3. We have A, B, and C. And then we'll get on to some examples. What are solutions to this equation right here? Okay, so what we're going to do is we are going to factor. And we learned this earlier in the year, how to factor with x to the 4th. If it's a trinomial, we can treat it like it's just like it's regular x squared and regular x. Instead of x to the x, you're going to have x squared, x squared. X squared, x squared. And then minus 4 and then plus 1. See, x squared minus 4, x squared plus 1. The inside and the outside, that combines to give you negative 3x squared. And of course, negative 4 times 1 is negative 4. So this does give you this polynomial. Now, set them equal to 0. Of course, x squared minus 4 can be broken down more. X plus 2x minus 2. This cannot be factored. It can't be factored with real numbers, so we're going to just use imaginary numbers. Now set these equal to 0. X equals negative 2. X equals 2. And then this is x squared plus 1 equals 0. Subtract 1 from both sides, and then take the square root. Square root of negative 1, plus minus I. Plus minus I. The radical negative 1 is just I, and of course you took the square root, so it's plus minus. Sketch a graph of this right here. Okay, so the graph, well, we need the real roots, 2 and negative 2. So if that's negative 2 and that's 2, I don't know how far down, I don't know how fat it is or whatever, but we can sketch kind of the function. We know it does what? We know it opens up, so we know it comes down through there, and then it comes back up. but it doesn't hit the x-axis, and then it comes back up. So that the sketch of something like that, we know it opens up positive x to the fourth, and we know it has that wiggle, and we know it only hits the x-axis twice. You don't really need, this is not really what about this lesson's about. You won't have to sketch that, but you know it only hits at 2 points. See this wiggle here? It comes up and back down. It comes up without hitting that x-axis again, and that's because we have imaginary roots. That's kind of what we're getting towards here. So how many x-intercepts does it have? Well, it has 2 x-intercepts. Now, we could sketch this with our graphing calculator, but we're not going to do that today. All right? Okay, so what did we learn from exercise 3? We learned that only real solutions are x-intercepts. So if it's a 4th degree polynomial, for example, if it's a 4th degree polynomial, you have to have 4 roots, but they may not be x-intercepts necessarily. We saw that one only had 2, even though there was a 4th degree. We had 4 roots, but only 2 of them were real, 2 of them were imaginary. Okay, so that's what's going to happen. Now, here's our examples here. Write a polynomial with lowest possible degree that has given solutions. All right, so if I have these solutions, this is pretty simple. I have p equals, p is the polynomial, p of x if you want to call it, whatever, it doesn't matter. Minus 2 is one of my answers, one of my solutions, so I know x plus 2 is going to be a factor. Negative 3 is a solution, so I know x minus 3 is going to be a factor. And then minus 4i, so it's going to be x plus 4i. And then 4i, so x minus 4i. There's my factors. 2 of them are real, 2 of them are complex. All right, so what I can do now, if I want, technically this is the well, to write a polynomial, it needs to be in standard form. So we want to write this in standard form. Well, we're just going to have to multiply it out then. So I can multiply these two right here easily. X squared minus x minus 6. That's easy. And then here, x squared, and then we practice this in the exercise 1, right? 4i times negative 4i, negative 16i squared, that's going to be plus 16. Hopefully you're getting the idea. When you get a 4i times a negative 4i, that's plus 16. 3i times negative 3i plus 9. 5i times negative 5i plus 25. Getting the hang of it there? Shortcuts. All right, now, whoa. A 3 by 2. I'm going to go to my tabular method. Set up my table here, 3 by 2 this time. Boom, boom, boom. All right, so I have x squared minus x minus 6. X squared plus 16. X to the 4th minus x to the 3rd minus 6x squared. 16x squared minus 16x minus 96. All right, so I have, what's my polynomial? P equals x to the 4th, and then I have minus, of course I forgot my placeholder. See how it didn't line up because I didn't put my 0x in there? Didn't put my 0x in there. I didn't get everything lined up. That's okay, though. It's okay. You don't need it. You just got to be careful. Only combine like terms. Minus x to the 3rd, and then these two combine, so plus 10x squared, and then minus 16x, and then minus 96. If you don't put the placeholder in, it's okay for multiplication. Division's where you get into trouble. All right, and then there it is. So there's our polynomial, 4th degree. It's got to be 4th degree. Oh, why? 1, 2, 3, 4 roots. Got to be a 4th degree. X to the 4th. See that? All right, now how about here? It looks like it's only going to be x squared, but we talked about a little earlier, you can't just have 3i, you must also have negative 3i. So even though they didn't give it to you, you know that if 3i is one answer, negative 3i is another one. So this one's going to be, we'll just call this f of x. F of x equals x plus 1, and then x minus 3i. This one's actually easier, and then x plus 3i. So now I have x plus 1 times, I know this is going to be x squared plus 9. We did that earlier. And this is going to be f of x equals, I can do this without, I can just do distributive. X times x, x squared. I'm sorry. X times x squared, x to the third. And then plus 1x squared. And then plus 9x and plus 9. X to the third plus x squared plus 9x plus 9 would be the polynomial that would have these given roots. Now, this one's pretty ugly. This one's ugly. Got to pay close attention here. If you could do this, you could do anything. I don't think they're going to give you one this hard, but we're going to do it just in case. All right, so ready? F of x, we'll call it f of x equals. 0 is just x. That's a factor of x, or x plus 0, right? So it'll just be x. Then we're going to have 2, so x minus 2. Then we have 1 plus I. Okay, that's x minus parentheses 1 plus I. See that? That's a factor. X minus 1 plus I. And then we have x minus 1 minus I. And this is why we did that opening exercise. Okay? So that's going to be x minus 2. Here, you know what? I'm going to put these together. X squared minus 2x. Let's put those together. X squared minus 2x. These two here multiplied together. And then this is x minus 1 minus I. That negative's got to distribute. We did it earlier. And then x minus 1 plus I. All right. Now, we got to do a 3 by 3 here. So I need a 3 by 3 box. Told you this lesson was going to get long. I apologize. We need a 3 by 3 to do these i's. And then we're going to need a 2 by something. Probably 3, right? All right, so x minus 1 minus I. X minus 1 and then I. All right, so x squared. This is algebra. Algebra, baby. Algebra. We love it. This is big boy and big girl math. Plus I. Got to be careful. Look at all those negatives and the 1s and the x's and the i's. xi, negative I, and then negative I times I, negative I squared is 1. We learned that. Plus 1, right? Negative I squared is negative 1, so that's plus 1. All right, so what happens? Well, we said our i's were always going to drop out when this is xi, negative xi. See that? Xi, negative xi. That's 0. I minus I, 0. Those i's should drop out if you did it right. That leaves us with x squared, negative x, negative 2x, and then plus 2. 1 and 1, right? 1 and 1 is 2. These combine for negative 2x and then x squared, right? So look at that. A regular polynomial. Our i's are all gone. Our i's are gone. We're not going to have i's in our polynomial. Okay, so now, now we need a 3 by 2. Mr. Ventry. All right, x squared minus 2x plus 2, x squared minus 2x. You don't need that last one there. All right, so x to the 4th minus 2x to the 3rd plus 2x squared minus 2x to the 3rd plus 4x squared minus 4. Big boy math. All right. There it is. We got it. We got it. We're ready. X to the 4th minus 4x to the 3rd plus 6x squared minus 4x. Just combining our like terms, right? Combine those like terms. There is our polynomial. Sorry, I just wrote over it, but that's the polynomial. One more example. Find solutions to this guy. Oh boy, all right, tricky. So 2x squared, no, 2x to the 5th minus 5x to the 3rd minus 3x. So I see this and I'm going to try and factor it. I'm going to take out an x. So I have 2x to the fourth minus 5x squared minus 3. Now this is one of the x to the fourth factors again, but we can handle this. We're going to factor this. 2x squared, x squared, and then 3 and 1, and the inner and the outer got to give you that 5x squared. It turns out that it's this, and I'll kind of show you. See how the outer is negative 6x squared, the inner is positive 1x squared. All right, so that gives you a negative 5x squared. I know that's kind of ugly, but we can handle it. All right, so x equals 0. X equals 0, that's that. Then we have to do 2x squared plus 1 equals 0. And we have to do x squared minus 3 equals 0. That's the easy one. X squared equals 3. Take the square root, square root. Did I mess up? Minus 3. Oh, it's plus 3. Plus 3 minus 1. But it's not. No, it's minus 3 plus 1. Okay, it's minus 3 plus 1. It is right. I had it right. Okay, sorry. So x equals plus minus radical 3. There we go. Plus minus radical 3. Now what happens here? We get 2x squared equals negative 1, and then divide by 2. So I get x squared equals negative a half, square root, x equals plus minus I over radical 2, okay? And then radical 2, we have to rationalize the denominator. X equals I plus minus I radical 2 over 2. So we have a lot of solutions here. 0, plus minus I radical 2 over 2, and plus minus radical 3. But what are our x-intercepts? Our x-intercepts are only 0, radical 3, and negative radical 3, because our x-intercepts are only going to be our real solutions. That I stuff, those aren't really x-intercepts. They're solutions to the equation, but they're not x-intercepts. Sorry about the length. We're gonna get better. We're gonna work on this and practice in class tomorrow. See you then.